صباح الخير للجميع. نرحب فيكم بهذه الجلسة الحوارية اللي راح تكون بعنوان رقمنة مرافق المياه والصرف الصحي، والتي نسعى من خلالها لاستكشاف كيف ستساهم التقنيات الرقمية في إحداث وتحول جذري في إدارة وتشغيل خدمات المياه والصرف الصحي في ظل التحديات المتزايدة من تقادم الانفراستراكشر أو البنية التحتية والتغير المناخي وشح الموارد المائية. أصبحت الحلول الرقمية تقدم حلولا مثل أنظمة العدالة الذكية والرصد اللحظي وتحليل البيانات والذكاء الاصطناعي أدوات أساسية لتحسين الكفاءة وتعزيز استدامة الخدمات. نجتمع في هذه الجلسة مع نخبة من الخبراء والمختصين لعرض تجاربهم الناجحة والدروس المستفادة في هذه الرحلة. أطلب من المتقدمين مستر مارتن، مهندس ملاك، الدكتورة نضال، تفضلوا على الستيج بلشوا بإعطاء المحاضرات المختصة بهذا المجال. السيد فادي والسيد مصطفى يبدو انهم اليوم مش راح يشاركونا، وهذا راح يعطي مجال للسبيكرز انهم يحدثون عن تجاربهم بطريقه اوسع واكثر. راح اترك كمان مجال لكل متحدث انه هو يحكي عن يقدم نفسه ويبلش بالعرض وعرض تجربته في هذا المجال. سيد
Hello everyone, I think you can hear me very well. So it's an honor for Veolia to be here today to make the presentation of our solutions and digital tools that we are deploying on the field for water and wastewater operations. So I will start with a very easy word and to show you how digital transformation is important in Veolia. These are the words of our CEO, so Estelle Brachenov, stating that, okay, in Veolia we want to be the world leader of the ecological transformation, but it has to go also with the digital transformation of the group. So it was a few years ago, and since that time we started to develop our digital transformation, and as you will see, coming from this strategy, after being the first worldwide in water services, in water technologies, the second in the world on the hazardous, first in the world for hazardous waste management, and also first in Europe as a circular economy actor, but also second in Europe on the energy district heating and even on the Europe energy efficiency services. Finally, gathering all this know-how and the knowledge and the opportunities to develop specific digital tools, we have finally developed our digital platform, which is named Upgrade. And Upgrade is a digital tool developed by an operator, which is Veolia, for an operator also. And as you can see, the success already of this platform, we have more than 10,000 sites already connected to the platform. We have more than 60 upgrade centers. And what is also important is, even if we are talking about digital, let's not forget that we have also to use human brain, the expertise of the group. So it means that even if we have developed this I would say digital transformation, it is with the expertise of the group, and as you can see on this slide, we have more than 450 experts that are also used via this platform in order to be connected with the sites and also reply to the questions raised, for example, by the operators. And to give you an example, at the bottom part of the slide, upgrade started in Middle East, specifically in 2019 with Enova. It was dedicated for the malls management in terms of heating, cooling, and then we have implemented this solution in 15 malls, so in UAE, Oman, Bahrain, Lebanon, and Egypt. And with this development, we have also developed for the water and wastewater solutions. But again, it's to show you also that in the region, we are already using Upgrade for the malls management. Then why Upgrade? Why this digital platform? First, for an operator, the first objective, the first step of a digital platform is, I would say, to be connected with the data. Okay? Because before, we had logbooks. Every operator was writing the pH value, the timing, the kilowatt hour consumption of a pump. And we had to retrieve those data from the copybooks if we were retrieving them. So it was quite complicated. But to have access online to this data and be capable to go to the next step, the first thing we had to do was to link the digital tool to the data. So since we are linking this data, first we are checking the accuracy of the data and the reliability of the data. We were talking about it yesterday. It was one of the questions. If you have a data, okay, but is it reliable? Can you really use it? So it's very important. As you were saying yesterday, garbage in, garbage out. So if your data is wrong, you will use the wrong data, and finally your conclusion could be wrong, and you could take the wrong decision. So it's very important. So this is what we are saying is, in fact, we have one single source of truth, okay? So we are verifying the data. Then, once we have the connection to the data and we are linked to the real time of what is happening on the field, we want to do the second step. So this digital platform are doing, I would say, data analytics, okay, for us. From simple ratio calculation, of course, to, I would say, deep data analytics, trying to see if there is any drift in the data, and so on. Okay? And this data analytics is providing you a vision of what is happening on the field. So, from the logbook we had before, where we were not exactly seeing what was happening to the field, now we are connected to the data, and even we see trends online, we see values online, so we know what is happening. And it means also that we can react, I would say, even more rapidly than before. And the next step, I would say, is the step of improvement. Okay? So, okay, we know what is happening, so now how we improve, how are we more efficient, how do we reduce our power consumption? Are we in the right range of specific energy consumption? For example, if I'm taking my plant, I know that usually a plant could be between 0.5 to 1 kilowatt hour per cubic meter for a wastewater treatment plant. Does my plant, is my plant ranging in this typical range, or do I have any malfunction, do I have any issue with my process that finally is impacting my power consumption? So with this data analytics and these improvement capabilities, especially linked to the expertise centers we have worldwide, we are sure that we get more efficiency, we are improving, and then for our clients we can also be efficient in terms of pricing for our O&M activity. So, yes. The next slide is finally okay. We have connected to the data, we are doing data analytics, and we are improving our O&M. But finally, it's not finished. And you know, we are all talking about digital tools, AI, machine learning, and now they are playing a very, very strong role and more on the efficiency and on many fields. So for example, here on this slide, you can see that we can use AI and machine learning on cost efficiency, adapt to the resource, water and energy consumption, chemical consumption, and so on. So our upgrade digital platform is finally a platform where we have developed many modules using AI or not, but improving, putting the digital in the middle of our activity. So in the coming slides, I will present you, again, I cannot be, I would say, accurate on any slide and develop every slide, but you will see a part of the modules that we have developed in order to optimize our field of activity. So the first one, the first application is an application based on the energy management. So the first module we have is the heat tracking module. So to go very fast on this module, finally this module is tracking the energy consumption of the pumping stations, the plants, on real time, but using AI machine learning, it can also predict or even analyze any deviation, any drift on power consumption and send us, for example, by mail or whatever, by text on our phone for one specific site that is drifting or is higher than the usual range or there is a malfunction, then we have an automatic warning saying, guys, be careful, there is an issue in this plant. Okay, so we can be very reactive, and even with all those trends and the machine learning, we can even predict what could happen if, for example, a plant is starting to drift. For us, there is also a reason, and then the AI is capable to, with the expert, is capable to explain why it's happening and then how, in terms of operation and maintenance, we could react and correct the situation. So yes, and in terms of reference, as you can see, for each of these modules, you will see on the top right the references we can have, where they are for each specific module. So here, for example, e-tracking has been developed and deployed in Colombia, France, Spain, Japan, Australia, and New Zealand. The second module is regarding the water resource application. So this one is named Water Resource Advisor module. So this module is allowing us to manage the boreholes where we are pumping the water to go to the treatment plant or to the distribution. So this module is quite new. So again, we are constantly developing new modules according to our needs on the field and depending also on the contracts we have. And this module first has references in France and Spain, so more than 400 assets are monitored by this module. And we have an ongoing pilot for the region in Oman for 25 boreholes, and we are currently discussing even in Jordan to deploy it with them. And this module, again, I will not go too much into details, but you are capable to see the borehole configuration, your pump activity, again, where it's located, what are the drifts, where we have issues, you have alert management and so on. Another example is the water loss management for water operations, very important for the region also, on the effort to be sure that we have a network, efficient network. So this, again, you have district metered areas, and then we have a tool where we are reprocessing the flows during night, for example. We are listening the network during the night also to see if there is any leak when there is no specific consumption by the population. We can visualize on a monthly basis. We can see also for each sector, you click on a sector and you have a detailed analysis on your sector, what is the consumption during night, during day, and so on. So again, this has been deployed in Ecuador, France, Spain, Morocco, and Tanzania. This one, for example, is not using AI or even machine learning, it's only data analytics, visualization, to allow the operator to, I would say, to have a response time as short as possible. Another one, again for water operations, but on the desalination part, so smart membranes. So this module, again, when you are operating, and when we are operating, for example, in Oman, the desalination plant in Sur, or in South Korea for Daesan 1, we have thousands of RO membranes to operate and maintain. And at some point, it can be a complex system in order to ensure that we are monitoring the lifespan of every membrane module. And this module, which is equipped with an AI and machine learning, so is in real time overviewing the operation of the membranes, checking the falling state, and then by learning is also capable to predict when a membrane will be fault and then when you will have to start a specific cleaning and so on. So with this kind of tool, again, by managing thousands of membrane modules, you are capable to clean the membranes when you really need it, because you may know that when you are cleaning membranes, you are I would say, edging your membrane. Okay, so it's damaging your membrane each time you are cleaning them. So it's very important for you as an operator to optimize your cost, to be sure that when you are cleaning a membrane, it's when it's needed, and not just because the operation manual is telling you you do it every X hours, for example. So it's very important for us, again, to have tools to optimize this kind of thing. On the wastewater operations, now we are on the network, so upstream the plant, so for the full sewer network. We have also the performance sewer module that is dedicated to link the hydraulic model, for example using ICM software, with upgrade platform in order to get the results from the hydraulic model, the weather forecast, in order to predict where the flooding will happen and when. Also, it is allowing, specifically in France, in some specific regions where we deployed it, it is also allowing us to manage the storm water, even to store the storm water in the network before going to the plant, to avoid any hydraulic overload of the wastewater treatment plant. We have also an example for plant itself, so for a wastewater treatment plant, so it's performance plant module. On the left side you have the typical control center of a plant, so the operator is managing the plant, but the plant you see on the right part is connected to upgrade, which is equipped with algorithms, AI, machine learning, in order to run simulations, predict what will happen, to try to stick finally more on the flow and the needs with the loads, in order, for example, of aeration and so on, and giving new set points to the PLC of the plant. So at some point, using upgrade performance plant, the operator has the possibility to continue with the usual PLC and then the usual automation system, or to use the results and the modification of set points by upgrade to run the plant itself. So if you, I would say you have an option of full run by upgrade module, so it means that at the end, if you let the module be 100% of its capabilities, upgrade plant performance can run your plant instead of the operator himself. Specific focus on the wastewater treatment plant is on the aeration system. Upgrade also has a Crea Pro module that is focusing only on advanced aeration control. So again, when you have this, we know that for a wastewater treatment plant, aeration represents 50 to 80% of the power consumption of a plant. So it's very important to be connected and to focus on this area when you want to do power saving and also CO2 footprint reduction. So with this kind of module, again, we have two different ways to manage. First is when you have turbo blowers, you can put in place the most open valve strategy. So it means that the AI will operate with the most open valve in order to reduce the dynamic pressure outlet of the turbo blowers. And we have also nitrogen and carbon modules that are using new sensors, I would say, yes, compared to usual. You put new ammonia and nitrates analyzers, and your system is capable to drive the plant according to these new parameters, to adapt to strictly what is needed for the oxygen, and then you are reducing your power consumption. And what you see on the right is, using this kind of system, you could perhaps be afraid that this system will, I would say, drop the quality of your treated sewage effluent, which is not the case at all, because as you can see, with the Crea Pro system in light green compared to dark blue, you see that the concentrations are lower than before, and we made savings. So 18% for Asama, for example, for the blowers. Since we implemented this platform, we have made 18% of savings on the turbo blowers, and for Doualance in Qatar, we have implemented only the most open valve module for the moment, and we already observed 8% of saving. We have the same for odor management. We are capable, again, in order to simulate what could be the odor dispersion, so using odor dispersion models, on hotspots of the networks, but also on the plant. Also, again, we have platforms. We can go online to see lively what could happen depending on the weather forecast, what will be the odor emissions around your site. I need 2 minutes. And out of all these modules that are very dedicated to the operation, you have also something happen in the group. It was in 2023. I was part of this and it was quite crazy. Is one day we received a mail from the IT team saying, from today, Veolia has its own chat GPT, so named Veolia Secure GPT. So it's the equivalent, but what is very powerful is in this Secure GPT, we have also, so we have the capabilities of chat GPT from 2023, and then inside we have fed the AI with all our best practices, guidelines, O&M manuals and all of this. It means that now, as a staff of Veolia, whoever is in Veolia, wherever he is, he can chat with the AI, asking questions on, I don't know, I am not an expert in Desal, I want to know how could be my operational parameters for my RO membrane. I'm asking to Veolia Secure GPT, and it will give me, it will resume, it will summarize to me all the guidelines, best practices he has in mind, direct to me, to give me the information I need. And to go further, because we did not stop there, quite recently, in Feb 2025, Veolia and Mistral AI partnered together to go to the next step. And the next step is we want to have a conversation with the plant. We want to have a conversation with the plant, not just asking questions like this, but we want to talk to the plant. So now we have a project named Talk to My Plant. So finally, this project of Talk to My Plant is giving a new generation assistance. On the left, you see the current situation. I have my operator and he is connected to best practices, to the cloud, to some archives, to the O&M manual, even to the touch sensitive, meaning that the routine he made the morning with the tablets giving the operation data, he is connected to all of this, but he is in the center. In Talk to My Plant, he is not anymore in the center. You see that in the center there is AI. And the operator finally is just contacting the AI. So he is not anymore, I would say, in the middle trying to get information from many sources, but the AI is having all the information and is in direct contact with the operator. This is what is changing. An example, we have an augmented operator. He has a chemical leak. He is not sure of what he wants to do, what he has to do. Perhaps he is a new joiner, he has not been yet trained and so on. So he will ask to the AI, okay, by phone, orally, in case of chemical leak, what is the necessary protective equipment and safety protocol I have to adhere to, and then the AI will reply to him. Okay, this is what you have to do, isolate the area, evacuate the area, notify the customer, so he has every step to follow. Also, currently we are on this side, so conversational interaction. So we write to our Veolia Secure GPT, we ask questions, and we want to go to the right side, where finally we are on our aeration tanks. We have issues, it is showing us pH is not correct. pH should be between this range and this range, so you should correct the situation by doing this. And for the end, finally, what we want to go even one step further is the new digital twin step, where finally, for the moment, we have the operator in the plant and connected to the AI, okay, taking the information and recommendation from the AI, to have the AI in the middle of the plant taking decisions, but of course under the control and the monitoring of the operator. Thank you very much.
Thank you, Mr. Martin, for this presentation, very useful presentation. يعني إذا نطلع على التحديات اللي عم نشوفها من الابلكيشن اللي عم نعرض علينا، نحكي لفيولا شكرا على هاي التول الكاملة، ونستنى الجيل الثاني اللي هو كيف يصير مع الاي ليصير هو يقوم بعمليه التشغيل الآلي والاوتوماتيكيه بطريقه مور يعني ادفانس وتشغيل بحيث يحدد كل البارامترز المطلوبه للتشغيل بكفاءه وفاعليه. هاي التولز فعلا اليوم اذا بتصير متوفره بمحطاتنا وباماكن التشغيل الموجوده راح تكون هي يعني خلينا نشغل بطريقه مو كفاءه وتكون احد الفوائد اللي هي موضوع الرقمنه والديجيتال ترانسفورميشن. رح نحكي البرزنتيشن الثانيه مع الدكتوره نضال حشيشو من هي مديرة قسم علاقات العملاء في مؤسسة مياه لبنان الجنوبي منذ عام 2009. دكتورة نضال حصلت على الدكتوراه في إدارة الأعمال من جامعة الجنان بلبنان. الدكتورة معها كمان بكالوريوس في المالية والمحاسبة من جامعة القديس يوسف. بالإضافة إلى ذلك هي مساعدة في عدة جامعات ومدرس في موضوع إدارة الجودة واللوجستيات. دكتورة نضال.
يسعد صباحكم. اليوم رح بحكي على مشروع منظومة الإبراج المائية ونظام أسكان. المحافظة على مصادر المياه وتطوير عمليات إنتاج وتوزيع المياه بطريقة عادلة وبشفافية كان من أولويات مؤسسة مياه لبنان الجنوبي. رغم كل المخاطر والتحديات اللي مرقنا فيها بجنوب لبنان، واصلت مؤسسة مياه لبنان الجنوبي التزوير والاستدامة بتقديم خدمات المياه حتى خلال الحرب. وأيضا وصلنا كمؤسسة عمليات تطوير لا سيما في مجال الإدارة الذاتية للمحطات. فكان مشروع ربط المحطات والمنشآت بغرفة التحكم المركزية وربطها بسكادا سيستم هي من أهم أولوياتنا حاليا. منا لهول المشاريع هو مشروع الإبراج. ليه مشروع الإبراج نحن بنعتبره هو النموذج؟ لأنه مشروع الإبراج أو هيدي المنظومة هي منذ تأسيسها كنا حاطين ببالنا أو كنا حاطين كهدف إنه نربطها مباشرة بسكادا سيستم. رح نبدأ العرض بلمحة تعريفية عن مؤسستنا لننتقل للتعريف عن مشروع منظومة الإبراج المائية وبعض الصور عنه، التعريف بنظام سكادا وفوائد هذا النظام وفوائد هذه المنظومة. مؤسسة مياه لبنان الجنوبي هي مؤسسة عامة أنشئت بموجب القانون 221 الصادر في العام 2000 الذي يعنى بتنظيم قطاع المياه في لبنان. مؤسستنا تعنى بتقديم خدمات المياه ضمن محافظتي الجنوب والنبطية، مساحة بتغطي تقريبا حوالي 2130 كيلومتر مربع من مساحة لبنان. وأيضا تعنى من مهامها تأمين المياه بطريقة مستدامة لمشتركين بالغ عددهم حاليا 194 ألف مشترك، هن موزعين على 8 دوائر وفقا للهيكليه بمؤسستنا. هن دائره توزيع صيدا، وبلشنا بصيدا لانه هي المركز الرئيسي للمؤسسه، وثم دائره سور، النبطيه، مرجعيون، بنت جبال، الزهراني، جزين ووادي شديد. رؤية المؤسسة هي الانتقال من مقدم خدمات إلى شريك فعال في خدمة وتطوير المجتمع. أما بالنسبة لمنظومة الإبراج فهي أكيد نفذت على عدة مراحل. هلا حنحكي عن كل مرحلة بعد شوي. ابتدينا بحفر بير ارتوازي ومن ثم إنشاء بركة لتجميع المياه، طبعا تجهيز المحطة وتمديد خطوط الضخ، تجهيز المحطة لضخ المياه، وطبيعي إنشاء الخزانات في عدة مناطق بيسرية، المريد، بسانية وتفاح بيتغذوا من الخزان الرئيسي تبع المحطة، وأخيرا تجهيزه بنظام إسكان. هون عم نشوف شوي عن مراحل تنفيذ هيدا المشروع. إذا بنلاحظ في عندنا بير، هيدا البير المتفجر رح نحكي عنه شوي. أيضا حفر الخزان الرئيسي بالصورة الثانية، والصورة الثالثة هي عبارة عن بناء المحطة. هون طبيعي تمديد خطوط الضغط، اوكي لتزويد الخزانات اللي موجودة بالمنطقة. مشروع الإبراج ابتدى بالبداية بحفر بير ارتوازي. هالبير عبارة عن بئر متفجر أو فينا نقول نبع طبيعي. ليه عم نسميه بئر متفجر؟ لأنه المي بتطلع فيه بطريقة طبيعية يعني لوحدها دون الحاجة إلى وجود مضخات. هذا البير بغذي تقريبا بيعطينا حوالي 300 لتر بالثانية، أي حوالي 26,000 متر مكعب باليوم. ثاني شيء عملنا هالمية اللي عم تفيض من البير تم إنشاء قناة تحويل. هالقناة عم نقيم المي اللي طالعة من هالبير لخزان لتجميع المياه، تم أيضا إنشاؤه هو خزان سفلي تم أيضا إنشاؤه بجانب البئر. وهالخزان بيجي فيه 3 مضخات. نحن حاليا نستعمل 2 ولكن الثالثة نحن تاركينها ريزر، يعني في حال خربت عنا مضخة بيكون في عنا مضخة ريزر لنواصل عملية التدفئة. هالمية اللي طالعة من هالخزان السفلي طبعا اللي عم نضخها عم تروح للخزان الرئيسي اللي هو موجود في محطة الإبراج. هيدا الخزان سعته حوالي 1000 متر مكعب، وأيضا من هيدا الخزان في عنا 3 منظومات مائية، هي منظومة النريد، منظومة البيسرية، وأيضا منظومة التفاح. وبعدين حنبلش بمنظومة الغسانية، هيدا بعده بيطور الإعلام. طبيعي تم إنشاء خط ضخ لحتى ننقل المي من الإبراج إلى النريد، وأيضا تم إنشاء خط ضخ من الإبراج إلى البيسرية للمنظومة الثانية، وأخيرا تم إنشاء خط جر من خزان النريد لخزان آخر هو خزان الغزل. طبيعي كان في عنا محطات قديمة نحن عم نغذيهم من محطة الإبراج، طبعا تم تأهيلها وتم إعادة تأهيل الخزان والمحطات والمضخات اللي فيها. وهيك اكتمل المشروع. ضل علينا انه نربطه بنظام اسكادا. شو هو نظام هيك اكتمل المشروع؟ شو هو نظام اسكادا؟ نظام اسكادا هو نظام لتحكم ومراقبة عن بعد. النظام بيقوم على مراقبة وتشغيل محطات ضخ المياه والصرف الصحي ومتابعة سير العمل فيها، بيعمل على توزيع المياه بشكل مستمر ومباشر، وهيدا نحن بنعتبره مساعد رئيسي لحتى نقدر نستمر بتأدية خدمات المياه بظل الأزمات الصعبة اللي نحن بنمرق فيها بجنوب لبنان وخاصة بالحرب. وهون بدي يعني اقول انه نحن خلال الحرب استمرينا بتغذيه المستفيدين من هيدا المشروع، اوكي، وفي عندنا حوالي 21 بلده بيتغذوا منه. هول ال 21 بلده نحن عم نسعى لحتى نفيد تقريبا حوالي 100,000 مستفيد من هيدا المشروع او مشروع منظومه الإبراج. ايضا مشروع او نظام سكادا سيستم بيساعدنا لنجمع المعلومات والملفات الخاصه بكل محطه. ابتدينا مثل ما قلت انا بمشروع الإبراج، ولكن لبعدين الله راد حنكفي بعده محطات تابعه للمؤسسه. طب شو الفائدة من تركيب نظام اسكادا وليه نحن عم نسأل؟ بالبداية طبعا تغطية البلدات بجنوب لبنان بالمياه وتأمين المياه العذبة لهم، ومثل ما قلت قبل شوي انه هيدا المشروع مثلا بيقدر بيوفر مياه عذبة او مياه للشتاء لأكثر من 100,000 مواطن، اوكي؟ ايضا ساعدنا بتأمين الحرب بتأمين المياه خلال فترة الحرب نظرا لأنه أنا عم نتحكم عن بعد، تحسين كفاءة التشغيل، العمل على تقليل التكاليف وتخفيف الهدر، وأيضا بمكننا من سرعة الاستجابة للأعطال فضلا عن جمع داتا بتساعدنا بعدين هلا حنشوف. أولاً بيساعدنا مراقبة فورية عن بعد، يعني نحن من خلال مركز المؤسسة، المركز الرئيسي للمؤسسة بمكننا هذا السيستم أو هذا النظام بمراقبة كمية المياه المتدفقة، المعدل الضغط، الفلوميتر، المعدلات الاستهلاك كل لحظة بلحظتها من مركز تحكم مركزي من دون الحاجة لأنه أنا يكون عندي فنيين كتار بكل موقع. وطبعاً نحن مثل ما بنعرف بخلال الحرب في ناس كثير هربت، ولكن في ناس انه اضطرت انه تترك، ولكن نحن كنا فقط عم نستعين ببعض الفنيين ليحطوا المازوت بالمولدات الكهربائيه اللي فوق بالحرب. ايضا هيدا النظام بيساعدنا لا في حال حدوث اي عطل او اي تسرب او فرضا صار في عندي انخفاض بالضغط، فهيدا النظام بيساعدني بارسال انذار فوري، اوكي، مما يعني بيسرع التدخل الفني لحتى نقلل من هدر الماء. ايضا بيساعد هذا السيستم على تحسين التوزيع والعداله بتوزيع المياه بشكل متوازن بين القرى المستفيده، يعني العامل الفني ما بقى في يقدر انه يعطي او يوزع المي لمنطقه على حساب منطقه اخرى، عم بيكون كله مراقب من خلال الغرفه المركزيه بالمؤسسه، وايضا هالمي عم تتوزع وفقا للحاجه وللاستهلاك الفعلي. يعني اي انقطاع غير مبرر للمياه عم يكون كله مراقب. طبيعي بما انه انا عم بنتج المي وفقا للاستهلاك الفعلي، هذا الشيء عم بيعود بوفر بالطاقه، اوكي، فهالنظام يتحكم بتشغيل المضخات والبوابات اوتوماتيكيا وفقا لحاجتنا، يعني ايضا بقلل من استهلاك الكهرباء وبيمنع التشغيل العشوائي او الزائد عن الحاجه، يعني انا ما فيني بقى ضغط وانا مش عايزه هالكميه اللي عم تتدفق من المي، قد ايه انا بحاجه نحن عم نضغط. بالاضافه لهيك في عندنا بيساعدنا هيدا النظام على توثيق وتحليل البيانات، فانا كل البيانات المتعلقه بكل المضخات نحن كلياتها عم تنحفظ، عم تساعدنا باعداد تقاريرنا الدوريه في حال كنا نحن بدنا نعمل تخطيط للصيانه المستقبليه، طبيعي عم نستعين بهول البيانات، شو صار في عندنا اعطال، وين كان صار في عندنا اعطال بالضبط، لحتى ناخذ القرارات من وين. يعني باختصار فينا نقول انه نظام اسكادا او اسكادا سيستم هو بمثابه عقد الكتروني باللي هو ضمن لنا او ساعدنا لحتى نمشي مشروع نبع البراق بكفاءه عاليه وباقل هدر ممكن. طب شو الفائده كانت عندي انا من هيدي المنظومه؟ هيدي المنظومة ساعدتنا بتأمين مياه الشرب بمناطق واسعة من جنوب لبنان، خاصة إنه كانت هيدي المناطق ببعض الأحيان تعاني من الشح والنقص الحاد في التغذية لعدة أسباب. ثانياً لأنه أنا صار في عندي بئر طبيعي، بئر متفجر أو فينا نقول نبع طبيعي، نبع البراق، ساعدنا بالتخفيف من الاعتماد على المياه الجوفيه، لانه هيدا المشروع بقلل الضخ العشوائي مثل ما قلت ببدايه العرض انه المي عم تتدفق لحالها، اوكي، وايضا انا عم بعرف قد ايه كميه المي اللي انا بحاجه لها، انا ما في حاجه لإلي انه انا ضخ كميه ماني بحاجه لها، انا عم ضخ وفقا لحاجتي، وهيك هيدا الشيء بيساعدني لحفظ المخزون الجوفي من الاستنزاف. واخيرا هيدي النقطة المهمة، دعم الاستقرار الاجتماعي، لأنه أنا هيدا النظام بيساعدني لأقدم خدمة، وخاصة إنه هيدي خدمة أساسية لحياتنا كمواطنين بشكل متواصل مستدام وبطريقة عادلة. هذا الشيء بخفف من تقليل النزاعات على المياه في جنوب لبنان. وهيك اكتمل المشروع، اكتمل نظام سكادا، والى اللقاء مع مشروع ثاني ان شاء الله بجنوب لبنان.
شكرا دكتورة نضال على هاي الفوائد اللي قدمت لنا اياها بخصوص نظام السكان. كيف كلنا بنعرف التحديات ويعني بنشوف قصة نجاح هذا النظام هو شيء كثير كويس. الآن بدي أقدم المهندسة ملاك معايطة من شركة المياه. مهندسة ملاك يعني احنا بنفتخر انه هو الذي معنا قطاع المياه هي سوت تغيير جذري بموضوع التحول الرقمي تقريبا القاعدة موضوع التحول الرقمي بشكل كبير. فرصة نستفيد نسمع منها عن تجربتها بشركة المياه اليوم شركة المياه عملت شغل كثير كويس على موضوع التحول الرقمي.
Hello everybody, thank you Engineer Ahmed for the introduction. Today I'll be presenting like a snapshot from what Miyahuna has did in terms of the digital transformation. And I'm happy today to see a lot of people who's driving that change from the operation team, Engineer Hussein, and Engineer George and Engineer Salim also from the hydraulic modeling. And we have also on board a new member, Engineer Hassan, who's also have an impact on, inshallah, the business intelligence. So thank you everybody, and let's start to deep dive on what Miyahuna have did. So going back to Miyahuna, because we have from Lebanon, so Miyahuna is representing serving the water and wastewater services for 1.1 million customers. So we're starting from Amman, the capital, and we move towards Zarqa and Hadaba. And for the digital transformation journey, I'll be covering the operational technology and the information technology and also the business intelligence. So if we go to the operational technology, so Miyahuna have the SCADA system since 2000, and then we will have a centralized SCADA system in 2007, and we have did an upgrade to the SCADA in 2014, and we have an expansion in 2019, and now we're talking about smart SCADA. Why we're doing this is to achieve the smart utility transformation. We have different objectives for the smart utility. We're not in Miyahuna moving toward the smart just to be following what is the trends, because sometimes people are following, they want AI because it's the trend nowadays. But Miyahuna, and since we have shortage in water, and since we have limited resources, we're looking forward utilizing the water in a proper way and distribute water in a balanced way. So we're not following the trends, and we have adopted many smart technologies. And believe me, we cannot just pick someone from on the shelf and adopt it here in the situation. For introducing IoT devices and smart meters, we are going to have 200,000 smart meters. We have a lot of IoT pressure loggers, but since this is designed for continuous supply, it was now we should have something dedicated to our situation. By the way, we have an intermittent supply. We have once per week water, and we have empty network for the rest of the week, so it's really challenging. So the objective of the project, it's still under running, and inshallah we'll launch it soon, to have an optimized water distribution, and to have smart network control, and to have real-time response. What we're talking about a real-time response, it means that to respond to the emergency cases. So in case of having shortage in one resource, we will have like an optimized operational scenario. So the project was designed like to have an eye on the primary system, because this is where our resources, and we're going into the secondary system to distribute between the district meters area, and we'll go to a pilot area where we have improved metering and monitoring, and convert into a smart intermittent regime, and we have a kind of smart utility within those areas. So we're also utilizing the artificial intelligence to get best operational scenarios, and like once you have the SCADA system in place, then it's easy like just to let the system run by itself once you're confident with the results. So for the IT, I'm not the IT expert, but the IT is like, as we have a lot of softwares in place. Now Miyahone is moving toward the ERB, and the ERB is like the project have a high mission critical server, because like in the session yesterday we were discussing the challenges. One of the challenges like to have like the data rooms to store the data. So we have high mission critical servers, and the security also is a key. So once you adopt like a new technology, you should think of the security, and specifically the cyber security. So Miyahone have core modules, which covers the finance, the HR, the inventory, and now we're working on advanced, which is the customer relation management, project management modules. So all the data and system will be connected together. So talking about the cybersecurity roadmap, in 2019 we were looking for the base and compliance, and then we moved to protection and detection to detect if there's like anything that could affect on the security, and we're looking enhancing the OT security. So I'll think about the business intelligence. So we're in the performance monitoring unit. Believe that the data should tell a story, and the data should lead to a decision. So because like I'm an engineer, and I'm representing the partnership of Hamburg Wasser, I need to tell you that I was in Hamburg for job shadowing, and like I was asking how you deal with the data. So I was thinking of, because some of the data is collected manually, so I was asking how you could trust the data, and how you could deal with the data. And I was surprised that they still have Excel sheets. It's not like not all the data are coming from systems, and we took that also on how to deal with the manual data, how to do verification protocols, because the data like coming from, the point is that you should start. Don't wait until you have all the IoT devices, because this requires a lot of funds. So start from Excel, collect the data, and then start to analyzing. It's as the data in the utilities are spatial, so we're utilizing the GIS dashboards, so we could know what is the performance of of each governorates, of what is the characteristic of each DMA. So we have one of the dashboards is dedicated to the NRW projects monitoring. So we know the targets, if we're achieving the target, for example, here we have targets for certain DMAs, and once we achieve the target, we have it as like in green. So the dashboard will make the life is easy for like the project management who's dealing with that project to see that if he's achieving the target, once there's a problem with one DMA, he deep dive and try to analyze, is it like a problem of the meters or a problem of more leakages on the pipes. We also have a dedicated dashboards for all KPIs, so it's ranging from HR dashboards to finance, and also to the technical, the operation, the customer service. Sometimes there's like KPIs that are affecting each other, so what is the effects? But like when you have the data as a dashboard, it will be easy for you to analyze. For example, this is a screenshot of how much we replaced meters in each quarter. So if, for example, the non-revenue water does not go down, we try to deep analyze, is it like the problem we did not replace the meter? Is it the problem that the meters should be changed now? It is the time for changing. We have a criteria, so we have that threshold where we could know how much meters you need. And I'm here want to tell you that we utilize the dashboard in developing the strategic plan. So as all you know, we're expecting the national conveyor to come. And Miyahon should prepare itself for this huge amount of water. And we launched our strategic plan in August 2024, and we utilized the data there to tell what is the project needed for the upcoming period, like for the 5 years before the national conveyor. So, like collecting data is not the target. The target is utilize what is the benefits that you're getting from the data. So the data should tell a story, and after that should lead to decision. And believe me, it's not an easy mission. In any AI project, I guess the majority of the work is on the data cleansing, the working on data, validating the data, and like the algorithm is there. You could train any model, and you will get the result. But if you don't have trusted data, so you will have a problem. And you should mix of what is called the data-driven model, which is based on AI, and the digital twin. And we're proud that we're working also on a real-time hydraulic model, where we have a digital twin to our network. So we have the SCADA there, we have the model that could predict what is coming in the 4 hours, for example, or 6 hours, and then we try to bridge in the gap to see where is the problem. So the digital twin also is needed, but you should build on trusted data, work in the data, and you should start even from Excel sheet. Like should start because it's really helped the utilities to improve their performance. Thank you very much.
ملاك على هاي البرزنتيشن الرائعة. إذا بناخذ دروس مستفادة من هاي البرزنتيشن نطلع إنه في عندنا بلان موجود الآن للتحول الرقمي، وكل الشغل اللي صار في شركة مياه ناتج عن خطة. هاي الخطة خطة التحول الرقمي. إذا شفنا المشروع تبع ديجيتال ترانسفورميشن بياخذوا منطقة عم بيحطوا فيها كل التولز بيس باي بيس وبيربطوا الداتا اللي عم تيجي من هاي المنطقة، وعم بيصير في عندهم تعديل على سواء كان نوع التولز او نوع السنسرز المستخدمه، سواء كانت ميترز او مش مش عم بيهتموا بس انه احنا بدنا نجيب داتا من الميترز او بدنا نجيب داتا من السنسرز، لا هاي الداتا اذا ما استفدنا منها وما ربطناها مع بعض وما كانت مفيده لمتخذ القرار مش بكثير انه بس نجمع هاي الداتا ونخزنها. اليوم عم نشوف هذا السيميوليشن كيف عم بيصير، عم بياخذوا غيري عم بيشتغلوا عليها، عم بيعملوا لها امبروف، وجدا الخطه تبعت شركه مياهنا بهذا الموضوع مقنعه وان شاء الله انها تكون مفيده. شكرا مهندس بلاك على هذه البرزنتيشن، شكرا لشركه مياهنا كمان على هذا الابروج. اليوم بدي افتح مجال امام الاسئله، بس قبل ما نروح للاسئله بدي يعني اليوم عم بنشوف سيستم عم ينبنى بشركه مياهنا، عم بنشوف تولز موجوده بفيولا سيستم بلاتفورم واتيفر. فلو بدنا نعمل مقارنه، احنا لو بدنا نيجي نطبق هاي التولز ديبلوي باليوتيليتي زي موجوده بالاردن، هذا الحكي ولا مناسب ولا المناسب انه احنا نبني كستمايز تولز ديبند على النيدز تبعتنا؟ سؤال من عندي لمستر مارتن، if you can answer this question.
Yeah, for the tools implementation, I would say all what showed this morning is available, I would say, and already deployed in many countries. And I was mentioning, for example, for the advisor that we are discussing even in Jordan with for down contract. So again, yes, it is possible. Still some modules are under deployment, but I would say most of the platform is available. Depending on the contract we have and also the needs of the client, we can deploy full platform, only a few modules. It depends also on the target, where we want to go in terms of performance, and where is already also the client in terms of performance. Perhaps he is already very high, so he will need only very specific modules, or he wants something from his operator that is easing the life of the operator, then we can deploy the full system.
Thank you. سؤال دكتور المهندس.
شكرا. عرفت بحالي مرة ثانية العميد مهندس يوسف مالك العيطان، يعني خلطة عسكرية مائية. طبعا I am proud بصراحة الآن إنه شفت أختنا من لبنان وملاك برضو الإكسبرت يعني من أوروبا والمنطقة وغرب. طبعا I am proud إنه بجنبي ترى واحد من نشامة مياهنا. I am proud إني أنا كنت واحد من مياهنا 10 سنوات و12 سنة في الإدارة المائية وسنتين في مياهنا. I'm proud what I'm seeing بصراحة يعني الفولي مانجمنت يعني بدها نايس كوميونيكيشن، وأنا متأكد إنه إن شاء الله نايس كوميونيكيشن موجودة، لأنه it is the best way إنك تصل لكل. طبعا الهاي ريسبونس والأكشن والرياكشن والرايت والجود مانجمنت، يعني هذه كلها بتودي للنجاح للسكسس. يعني أنا am proud إنه بكرة عندي محاضرة في success stories عندي water utilities management. فقطاع المي مهم جدا في المنطقة العربية، قطاع المي مهم جدا في الأردن. أنا متأكد من السكسس ستوريز في الإدارة المائية مياهنا، وإحنا شايفين شباب ما شاء الله، يعني إن شاء الله يعني متفائلين جدا فيه. شكرا.
Hello everyone, this is Salim Khisat from Myanmar, and I have a question for Engineer Martin. So, is it that easy to provide a comprehensive solution for the digitalization of the water and wastewater networks? Because actually from our experience, we had a lot of problem in collecting geodatabase, the water network itself. It is the biggest achievement we have done in this project, is to make it accurate more than 90% on the primary system. We are talking about 800 kilometers of pipes, and there was a lot of valves, there was a lot of missing data, there were a lot of not correct diameters, and all of those things concerning and affecting the precision and the accuracy of the results that you have. So with your unified platform, at the beginning, do you have some solutions for the water networks? This is one. And the second one, what is the accuracy of your results? And thank you.
Okay, thank you for your question. I raised the point yesterday during another session, so you're right for the network. It's an issue for everyone, so I will not say it's easy, we implement the platform like this and it's working alone on its own. No, I would lie if I was saying this. It's a tough work, it's a difficult work, taking a long time, calibration and so on, so like you, I have the same experience, and if I can say even my past 4 years in Qatar with Ashgal on the Qatar North Catchment Zone, we had to, for the client, we had to model the full sewer network and surface groundwater network to deal with the issues of the flooding each time it's raining, even if it's raining once a year. And the first issue we had was the GIS. So as you are saying, the GIS was there, the client was saying, you have the GIS, so now please run the model, do your job, and so no. Finally, we went on site, and it took 8 months to update the full GIS, to have the right height, manholes, dimensions, pipes, diameters, whatever was there. So 8 months of effort on the field to fill in all the data for the network, and then we could work on the model itself. So for sure we face the same difficulties. So this kind of tool, which is very powerful when it is calibrated, when it is filled of real data, trustable, reliable data, then you go on the calibration, which is also another issue because you have to run a few, I would say even few flows that are not existing, because when it's running only one time a year, how do you calibrate exactly your model? It's not so easy. After, if you go on the drinking water, it's another matter. But so again, each phase is quite complex, but at the end, when you have the calibrated stuff, it is working well. And for the accuracy, it depends of also what is requesting the client. But usually, if I'm talking about the full sewer network, what was asking the client is to be for the accuracy, if I remember well, for the runoff model, we had to be at 20 centimeters for the flooding reality. So after we had to calculate with past data, when they are existing, to see if with the model we were, I would say, at the same level of flooding that was observed before. But again, it was very complicated. Perhaps in Jordan it's not the same case than in Qatar or in UAE, but in Qatar and UAE, especially in Qatar with the World Cup, the last past years, I would say buildings were growing like this. You were waking up one day, one more tower compared to the previous day. So again, when you are comparing data, but when the configuration of the whole system has changed, it's an issue. So I think that for the Qatar topic, for example, we are not sure that we are having the accuracy that was requested, but it will be in the coming flooding, let's cross fingers that there will not be, but I would say some waterhead somewhere where water is stagnating, then we will compare. I hope I replied to you.
Hello, this is Zainab Shahadi from WE Lebanon. My first part of the question is for Dr. Nidar. What is the challenges you face on the SCADA system? And the second part is for Malak, Engineer Malak. Since you have more experience in SCADA, what is the same question, and please can you tell us the best practices you do? Thank you.
بالنسبة للتحديات أو التشالنج اللي نحن واجهناها، أكيد في عنا عدة تحديات. في عنا قصة التمويل، والحمد لله قدرنا نتغلب عليها هالمرة إن شاء الله دايماً بعبر الدونرز. اما بالنسبه للكادر البشري طبيعي جبنا كادر جديد وفي قسم من الكادر القديم عملنا لهم دورات تدريبيه واهلناهم لحتى يواكبوا العمل على نظام اسكادا. هلا في قصه هلا في بعد ممكن قصه كمان توليد المولدات. الحمد لله قدرنا هيدا الحرب خلال هيدا الحرب مرقت انه كان في بعض الموظفين فوق قدروا يطلعوا يحطوا يغذوا المولدات بالمازوت ولنستمر بعمليه الضخ.
Thank you for the question. I want to add to what Dr. has mentioned. The funding of establishing such a project is one of the challenges. And in Jordan, we have like several funds, so we could have the SCADA systems. But again, as any technology, you should follow an update. So if we're talking about the OT, the operational technologies, then you should have the update and replace whenever it's necessary to replace, so you don't have an outdated equipment. But again, you should do the optimization of what IoT devices you need. So it's not necessarily to introduce or to have all your meters smart, or you have an IoT device spread along the network. But you could start from, for example, the primary system or like the district meters area, and then you start expanding the work. So you could have a pilot in one place and like to get benefit what is the best suitable for your situation. And maybe like for us, we tried like the smart meters, but we find like smart meters alone is not enough because it's not suitable for the intermittent supply. So we were thinking of having smart meters with shut-off valves on the house connection. So it's a matter of knowing what exactly you need, and to start from like I'm showing the pyramid because like start from the primary system. So start to figure out what is the resources you have, and then go to the DMA level and find out what is the need that you request. But I totally assure that the SCADA system is something that could add value to you because you're seeing what is happening. So it's really a need. Like it's not like something fancy that you just want to adopt, but like you need to see what is going on the network. So.
السلام عليكم، مهندس محمد فارس. سؤالي للمهندس نضال بخصوص النبعة اللي حكيت عنها، النبعة متفجرة أو السورس هذا. كيف آلية الكنترول تاعت الفلو تاعتهم؟ كيف تقدروا تسيطروا على الفلو، خصوصا إنه أنتم مالكم بتوردوا، وأكيد السحب للإند يوزرز مش ثابت على مدار اليوم، فحيكون في تذبذب بالسحب. فكيف انتم بتعملوا كنترول على السورس، خصوصا اني انا شفت الستورج كاباسيتي اللي حاطينها في المناطق اللي بتوزعوا فيها مقارنه بالفلو اللي بيطلع اليومي من النبعه كثير قليل. ان شاء الله بس يكون مفهوم السؤال.
ممكن ترجع تعيد السؤال.
يعني الكنترول هاو تو كنترول ذيس سبرينج فلو، لانه بتعرف هو ارتيزيان و it is flowing without any forced bumping also.
هلا بجاوبك على هذا السؤال زميلي المهندس آسي رئيس مصلحة الدراسات، لأنه هو هذا من مهامه لعلم.
ممتاز.
اوكي، مثل ما انت تفضلت هو ارتيجيان ويل، وبالتالي المي هي مع قاسم خليفه رئيس دائره مراقبه التنفيذ بمؤسسه مياه الدرينج بالدي. مثل ما تفضلت هو ارتيجيان ويل، وبالنهايه الكنترول على الفلو كثير صعب او مستحيل اذا بدك. وبالتالي نحن مثل ما انت تفضلت انه الكميه اللي نحن عم نسحبها حاليا منا قد الكميه اللي عم تطلع من الوادي. لان بعد في مشاريع مثل ما تفضلت المدام نضال مثل الغسانيه بعده ما تم، يعني نحن بلشنا بالبروجي تقريبا من حوالي سنتين، عملنا 3 بارت منه، بعد عملنا اجزاء منه ما كمل. فحاليا الفائض عم بيروح كاوفر فلو على البحر، ما في اي طريقه ثانيه حاليا.
هذا الجواب اللي كنت اساله. شكرا يعطيك العافيه. بدنا اياه على عماني.
انا عندي سؤالين.
يعني نبعد هو مقابله حديثكم نبعد بتحكي عن 26 يعني 1000 متر مكعب بير اور.
صح.
يعني احنا ما في عندنا هذا الحكي بالاردن.
صح. هو اصلا حاله هو اصلا هذا الوين هو حاله استثنائيه. هذا الوين هو حاله استثنائيه نتيجه يعني الفورماسيون جيولوجيك، يعني ثابت بهذه المنطقه داخل الاوسم مع الكريتاسي نتج عنه هذا المرح.
هلا بس انا مداخله للنقطه هذه مش سبرينج بس
لا هو ويل.
انتوا سبرينج.
هو ويل.
وين؟
اهل المنطقه اللوكال يطلقوا عليه ويل نتيجه طبيعته المتفجره.
يعني سوري اذا كان ويل اذا محدد المجرى تاعه من تحت ومعروف.
صح.
تمام؟ يو كان كنترول ذا فلو.
لا ما لك شغله. قلت لك هذا الويل استثنائي نتيجه الفورماسيون جيولوجيك للمنطقه، الطبيعه الجيولوجيه للمنطقه. بهذه المنطقه ميري فولت. هذا الفولت سمح للميه الكريتاسي والايرثين على طبقتين من المياه انهم يتداخلوا مع بعض. اوكي؟ وبالتالي صعب علينا انه نحن نعمل كنترول.
هي المي اذا بنرجع للصور بس عفوا استاذ اكوان، هي اذا بنرجع للصور بالعرض مبين باحدى الصور كيف المي عم بتفيض لحالها. هو هيدا البير بيوقع على الساحل والمي عم بتفيض لحالها.
موضوع جدا ديسكشن سبيشال ديسكشن بينكم.
تفضل استاذ عمر.
خلينا بس نكمل اسئله وفي سبيشال ناخذ سؤالين هون.
Jay, لو سمحت. أنا I have a question for Michael, please. Concerning the modules that you have presented, I have seen very interesting modules. However, did you have any module? Do you have any module concerning testing and of the water quality?
Yes,
And in order to control directly safety of water, since you have to provide potable and safe water to all customers.
So I'm not an expert on this drinking water part. However, what I know is we have modules that are simulating sensors. So I don't know if it is your question, but it seems that using AI and so on, we are capable to have digital sensors that are not existing on the reality on the field, but using, I'm quite sure, the hydraulic models of the network plus the FRC level or whatever the parameter we are following, we know what is the quality at this point, even if there is no sensor. After, for I would say general drinking water network, I'm not an expert, but I'm quite sure that we are deploying many sensors in the water network to be sure that at, I would say, the inhabitant level, when he is opening the tap, it is fully compliant.
My second question to South Lebanon Water Establishment and Maha, same question. بالنسبة لتطبيق سكادا بالمنظومتين اللي حكيتوا عنه، إذا فينا نعرف شو النتائج من قبل ما حطيتوا سكادا وبعد ما صار سكادا، شو هي النتائج اللي لمستوها since نحن عم نحكي عن ويفي، يعني من خلال الانرجي، من خلال الووتر، قد صار في عندنا leak detections directly عم تقدروا تعرفوها. Please يعني can we get results data?
هلا نحن بالنسبه للنتائج انا حكيت بنهايه العرض انه كان في عندنا تخفيف بالنسبه للنتائج انا حكيت بنهايه العرض انه كان في عندنا تخفيف استهلاك الكهرباء لانه نحن عم نضخ حسب الحاجه، وايضا التوزيع بطريقه عادله للمستفيدين من مياه هيدا النبع. يعني بالسابق كان يصير في عندنا مثلا بعض المناطق تنقطع ما تتحول او ما يكون في عندي توزيع عادل لها، ولكن هيدا المشروع وعبر السكادا سيستم خلينا نراقب كيف طريقة التوزيع ونقدر نشتغل على العدالة بتوزيع المياه. خلاص.
I will go back to the KPIs. So it's a matter of what the utility needs. So you could implement the SCADA system in order to achieve certain things. So, for example, you see that the journey of Miana started too early. So we're talking about SCADA in 2000. And at that time, it was aimed like to monitor what the resources, what water do we have, and how we could distribute it. And then the need come to, we have, for example, commitments to reduce the non-revenue water, so we utilize the data. So you should think of what is the target of the project or the SCADA. And again, like you continue the journey as like to utilize the data for direct the investment. So yes, we have achievements in reducing the non-revenue water. We have achievements, for example, in having balanced distribution. So once you have the SCADA, you know that. So it's enough like. On a daily basis, engineer is the operation manager is looking at the SCADA, and you know that no stop for this filling this tank and diving the water to other areas. So it's a matter of what you want or what's the target of you, and at the end of the day you should have a roadmap. So once you know where you're going, so you could, for example. Sometimes you don't need like to go to the AI, so it's enough. Like at this stage, I just want to add a couple of sensors to measure the quality. And what Engineer Michael mentioned that the digital twin concept, and that we'll be adopting here. So going back to what is the model. So the model could be like a data-driven model. So you have a data, whatever the data, the weather forecast, quality, and you could know the relations. And you could have like a physics-based model. So you know the equations, the physics behind the system. And that's what when you the digital twin step in. So for example, the hydraulic model, it's not necessarily to have sensors at every kilometer of your network, but the digital twin concept is like to have what is called a virtual sensor. So after 1 kilometer, I know that the flow will be like this, or the pressure will be like this. So it's like to optimize where to put the sensor and to know to utilize like the physics behind, because we're talking about hydraulic science.
Yes, and if I may add also, for the SCADA, I have an example. We have a contract in Saudi Arabia, in Jeddah. We are refurbishing and operating 5 plants. And the SCADA is the main point, because first we are doing the refurbishment during 1 year, and then we are operating. And for example, for a private company like us to have the best efficient technical and economical offer, at some point we have to take also into account the head count of our operation team. And for example, putting in place SCADA is allowing us to reduce the head count on one side, so to be more efficient, or if we don't want to reduce the head count, at some point in our offer we could say that, okay, having the SCADA and not driving in manual mode the plant anymore is saving, I don't know, let's say 15 people, 20 people, and then these people we can relocate them in another contract, or if they are staying in the contract, perhaps we will focus more on the maintenance and we will change, for example, the asset management way that we did not do during 2 years because we did not have SCADA, but then having the SCADA, it can make also savings somewhere else. So headcount, having another strategy for the maintenance, so for me SCADA is very important, and for the digital platform that we are implementing further, with no SCADA, it's quite impossible, because finally the SCADA is the heart of the data. So we are collecting, I would say, 80% or 90% of our data from the SCADA. So if the SCADA is not existing, all these smart platforms and so on, it's difficult to implement them.
الدسكشن عم بيصير كبير، في عنا بس ناخذ اخر سؤالين عم بروح الوقت.
Okay, Dr. Mu'tasim Shaban, Destination Advisor from GIZ. I have a question to Engineer Malak. mainly about data verification or trusting the data. At the end, we have maybe flow meters or pressure sensors from the network, from any water facilities, and you receive this data. You mentioned also that you went in Germany and you discussed with someone about the trusting of the data. So I would like to hear from you what's the conclusion you have now, how we can verify the data, and what's the plan of Miyahara. What Miyahara does in this regard. Do you verify the data collected from the meters, from the sensors, and if yes, how often do you calibrate or verify calibrate the equipments, and what's the procedures or methodologies that you are following?
Okay, thank you for the question. We have also here Engineer Falah, forgot to mention him. He's the guy who's doing the verification. So yes, we receive the data, flow data to the SCADA, but like sometimes you do the analysis and see it's like abnormal, there's a problem. So we request him like go and install additional meters for verification. So yes, the verification is there, and we also do, we have also a test bench to test our meters, like the customer meters, so just like to make sure that we're getting correct results from the instrument, let's say. In terms of what we're doing here with the hydraulic model, we are also comparing what is the hydraulic model giving us and what's the sensors, so it's a kind of calibration for the model. And the data itself, let's say the performance data, is the verification protocol is done like by see what is the relation between two performance indicators. So for example, if like the number of customers is X, and then so I cannot get a real example, but like sometimes like two parameters could give you an indicator. Like if some parameter is increased while the other is decreased, there's a problem with your data. So it's a matter of what you're looking forward. So you should establish that verification protocol. And yes, we have a partnership with Hamburg Wasser, and it's part of what the exchange and knowledge is like to have a job shadowing, and I've been there for to see what their experience and monitoring the performance, how they deal with the meters. So we think like here in the Middle East that the Europe will have the smart meters or like the fancy sensors, but like when I go there, they have a scheduled meter replacement, and they know that they don't need at this time to replace all the meters with the smart meters. So that's why I insist, like, it depends on the case, but you could get benefit of whatever the situation. So.
Because we have the last question.
Just very quickly, on the Veolia side, I would say we are not doing magic, but AI is very important in this matter, because finally, as you were saying, AI can use the model results, can use the different sensors of the zones values, and then can even tell you, because you have experts that teach the AI how to check. And finally, in our platform, for example, we are using AI to tell us which data is reliable or not, or which sensor we should check or not. Of course, you have random check as everywhere to be statistically to be sure that everything is fine, but we are using AI in this matter specifically to identify which sensors we should trust or not, and then it takes a decision to take, for example, the model value instead of the physical value that you have on site.
Thank you. Thank you for the presentation. So, Laurent Poiret, I'm in charge of Veolia for Jordan, Lebanon, and Egypt. And I have just a few comments. First, digitization is to take better and quicker decisions. And first, I would like to say that I'm impressed by Jordan and what you do in Miyaona each time. I discussed with Mohamed Oran or with you, Malak. I'm impressed because there is a roadmap. There is a roadmap, and you see that the roadmap is ongoing. And I would like to come back on one of your questions at the beginning of your speech, which is upgrade the availability of upgrade. So within Veolia, we are implementing upgrade in each of our contracts. For instance, SAMRA or DZMN operational maintenance. We put it, generally speaking, in our proposals. For instance, on Yarmouk management contract, it's part of the proposal. And what I would like to take is that I think it's alive. It's something which is moving. We are lucky to be able to, I would say, the keyword is integration. Integration of knowledge, but it's more than knowledge now. It's the contract, the experience, which is within each contract that we have worldwide. And it's true that Jordan is complex because you have intermittent supply. So you have something which is quite different from many, many contracts. But we can as well integrate that. And luckily, I think it's as well because we have very long-term contracts. I think about one that you visited Jordan, which is one that we have in France in Sédif, which is the biggest contract around Paris, where I think the General Secretary of WAJ and the General Secretary of the Minister of Environment, they visited us 2.5 years ago. It's such type of contract which is huge, which is long-term, where we are able to integrate the things to make that these developments of upgrades are developed and tailored to the cities of Amman or the cities of Paris. It depends on that. So that's this long term and this number of contracts which makes that you are able to develop so quickly the modules. That's was a few comments. Thank you.
Thank you. This is the partnership, the PPP partnership, public-private partnership. So this is the model how we can work. Thank you everybody. شكرا للجميع اللي حضروا الجلسة. جلسة جدا كانت استفدنا من الخبراء اللي معنا. وجلسة كانت جدا رائعة، والأسئلة كانت موجودة، كمان استفدنا من أسئلتكم وإجابة الخبراء اللي معنا زملائنا. شكرا للجميع.